Select the major product of the following reaction sequence. So we are starting with an unsubstituted benzene, and we have two reactions that we're doing. And so the first thing that we're doing is we're taking this benzene ring and we're treating this to a mixture of nitric acid and sulfuric acid. So you want to recognize that these are the conditions for a nitration reaction. So we're adding an NO2 to the benzene ring. And so when you start with an unsubstituted benzene, you can put that NO2 anywhere on the ring because no matter where you place it, you're just forming nitrobenzene. So I am just going to put it right here. But now the second group that we add, it's going to be important where we add this because now we have a substituent on the ring, and we know that the substituents on the ring have directing effects. They're either going to direct an incoming nucleophile to the ortho and para positions or to the meta position. So let's take a look at this nitro group. Let's go ahead and draw it, because with the nitrogen we might be tempted to think it might have a lone pair of electrons on it, which would make it electron donating. But in the nitro group, it doesn't. So when we draw this group out, we can see, and we know there's no lone pair because we've got 4 bonds. This is a second row element. It cannot exceed an octet, so it cannot have more than 4 bonds. And you actually have a positive charge on this nitrogen. So this is actually a really, really powerful electron withdrawing group, and we can pull these electrons out, much like we've seen with carbonyls, but actually an even stronger effect. So nitro groups are strongly electron withdrawing. So strongly electron withdrawing group, we will say. And this is a meta director. So because we have added the nitro group first, the nitro group dictates where our second group is going to add. So our first conditions were the EAS nitration conditions. Second conditions, these are conditions for adding a bromine. This is a bromination. And so once we've added the nitro group, that nitro group is going to direct the incoming bromine to the meta position. So that means our product will have that NO2, that nitro group, and we can put the bromine either at this meta position or this one. It doesn't matter. They're the same thing. And we just want to find the product that has the nitro group and the bromine 1,3 to each other right here. Okay. And the only other option I want to point out here is C, is the sulfonation, because sometimes students will get sulfonation and nitration confused because they both involve sulfuric acid. The key to telling them apart is the presence or absence of the nitric acid. We see that we have nitric acid, that means we're doing a nitration. If we didn't have the nitric acid and we had only the sulfuric acid, we would be doing the sulfonation.